Assalamu alaikum warahmatullahi wabarakatuh. Welcome back with a new lecture with method validation. Last time we were discussing F-test. I said that F-test used to compare between the variances of two groups of samples, and that will be used to compare between reference method and another method used to analyze the same parameters but developed and validated inside the lab. And you want to ensure that you can get accurate and reliable results using this method. And also can be used to compare between the performance of two instruments to ensure that you can get the same performance using both of them. If you have instrument, old instrument, and you got a new instrument, and you want to ensure that you can get the same performance using these two instruments. You can analyze from 6 to 10 replicate of spiked samples using reference method and the lab developed method. Then you will get the standard deviation, calculate the standard deviation for each group, then the variance for each group, and the variance equal to the square root of standard deviation, square root of standard deviation. Then F experiment, which is equal to variance, the square root of variance for group 1 divided by the square root of variance for group 2, and here you will add the larger variance, here the smaller variance. Then you will calculate F critical value from F table at confidence level 95% or alpha error 5%, or alpha error 5% at degree of freedom n -1. If the F experiment will be less than F critical, in this case there is no significant difference between the two groups of samples, and you can use the lab developed method to get accurate and reliable results with same performance like the reference method. But if the F experiment higher than F critical, in this case there is a significant difference between the variance of these two groups, and you cannot use this developed method to analyze your samples, but you should develop again this method to get accurate and reliable results. But today, inshallah, our lecture will be around T-test. T-test used to compare between the mean of two groups of samples. So used to test if there is a significant difference between the mean of two groups of samples, to compare between the performance of two instruments used to analyze the same parameters, or to compare between reference method and lab developed method, which is developed and validated inside the lab, to ensure that you can get accurate and reliable results using lab developed method. There are many types of T-test. T-test can be divided into unpaired T-test and paired T-test. And unpaired will be divided into with equal variances and with unequal variances. If you will compare between two instrument performance using 10 replicate of spiked samples, so in case of unpaired T-test, you will analyze 5 replicate of them by one instrument and the other 5 replicate by the other instrument. You will not analyze the 10 replicates by both of them. So these two groups are independent on each other. Different replicates will be analyzed by the two instruments. In case of paired test, the 10 replicates will be analyzed by both of two instruments, by both of them. After that, you will calculate the variance for each group. In case of unpaired, you will calculate the variance for each group. Variance for each group. Then you will calculate the F experiment, which is equal to variance, square root of variance for group 1, divided by square root of variance for group 2. Then you will calculate F critical. And if F experiment will be less than F critical, as we said before, that there is equal variances. There is no significant difference between the variance for each group, for the two groups of samples. There is equal variances, so you will use this case. But if the F experiment will be higher than F critical, so you will use this case with unequal variances. Unpaired t-test with equal variances. As we said, we will analyze replicate of spiked samples using the two instruments, one instrument and old and the new instrument. As example here, you will analyze 6 samples, 6 spiked samples, and here 5 spiked samples. They are different. And then you will get the standard deviation, then you will get the variance for each group, which is equal to standard deviation, square root of standard deviation. Then you will calculate the F experiment, the square root of group 1 divided by the square root of group 2. And if the F experiment less than F critical, so this is our case, which is equal variances. Equal variances. Now you will use the equation for this type of t-test, unpaired t-test with equal variances. So if the population variances are equal for the two groups, in this case we will pull the sample variances together to get a single estimate of the population variance, which is pooled sample variance. Pooled sample variance is p squared equal to number of replicates for group 1 minus 1 multiplied to the variance for group 1 plus number of replicates for group 2 minus 1 multiplied to the variance for group 2 divided by the degree of freedom for the two groups together, n1 plus n2 minus 2, which is coming from n1 minus 1 for the group 1 plus n2 minus 1 for the group 2. It will be equal to n1 plus n2 minus 2. So this pooled sample variance will estimate the common population variance. Estimate the common population variance for the two group of samples. Finally, this is the equation to calculate T experiment in case of unpaired t-test with equal variances. T experiment equal to absolute average of group 1 minus average of group 2, and we need to add absolute before because maybe the average of group 1 will be less than average of group 2. So in this case will be negative, and we should have positive result at the end, divided by SCP, which is equal to square root of SP squared, which estimate the common population variances between the two group of samples, multiplied to square root of 1 divided by number of replicates of group 1 plus 1 divided by into number of replicates of group 2, which is equal to absolute average of group 1 minus average of group 2 divided by SP, pooled variance, multiplied to square root of n1 n2 divided by n1 plus n2. And this one, which estimate, this is the standard error, named standard error, which estimate the true standard deviation of the sampling distribution of the difference in the sample mean, between the two group of samples. Then we will get T critical value from the T table. If T experiment was less than T critical, in this case there is no significant difference between the mean of two group of samples. But if the T experiment was higher than T critical value, in this case there is a significant difference between the mean of the two group of samples. And now let's have example to clarify how to calculate T experiment using Excel sheet. In this example, I analyzed 10 replicate of spiked samples using reference method and in-house method. Used to analyze the same parameters, I got these results. Number of replicates was 10 for each group. The average, we have to calculate the average because we will use it after that in the T experiment equation for each group. And then standard deviation for each group, the variance for each group, which is equal to the square root of standard deviation. Then F experiment, which is equal to the variance of group 1 divided by the variance of group 2, as we explained in the previous lecture. F critical from the F table equal to 3.18, and if experiment 2.34. So if experiment less than if critical, in this case there is an equal variances between the two group of samples, and we will use unpaired t-test with equal variances. SP, this estimate the common population variance of the two group of samples, and SP, the square root of SP up to 2, which is equal to this. And then we will calculate at the end T experiment, as we said in the equation, absolute of the average of group 1 minus average of group 2 divided by SP multiplied to square root of N1 N2 divided by N1 plus N2. We got this number 1.51. And we can calculate T experiment by easy way using data analysis, as we explained in the previous lecture. T test assuming equal variance with equal variance. Okay, group 1, group 2, alpha error at confidence level 95% or alpha error 5%, 0.05. And here we can add our result here. Okay, we will compare between our results and these results. The average of group 1 4.22, 4.22, 4.13, 4.39, 4.14 for group 2. Then the variance for each group 0.008, 0.019, same 0.019. Number of replicates 10 and 10. Pooled variance 0.0138, 0.013. Pooled variance. Then degree of freedom, as we said, N1 plus N2 minus 2. We have 10 replicates for group 1 and 10 replicates for group 2. Minus 2, it will be 18. And T experiment equal to 1.517. Then we will see T critical we can get from the T table. In this table, at confidence level 95% or alpha error 5% or 0.05, add number of replicates here. We have 20 at degree of freedom, 20 minus 2, 20 minus 2, 18, 18.05 here, at 18, 1.734, 1.734, 1 T critical 1.734. So T critical will be equal to 1.734 and T experiment 1.517. So T experiment less than T critical. In this case, there is no significant difference between the mean of two groups of samples. That was the end of our lecture for today. Inshallah, next lectures will be around how to calculate T experiment using other two types, unpaired T-test with unequal variances and paired T-test. Thank you and see you in the next lecture, inshallah. Assalamu alaikum wa rahmatullah.